Hello and welcome to today's episode of One Man and His Whiteboard. Today we're going to be talking about bits and byte, or bits and bytes rather, in networking. So when we talk about bits and bytes and how they operate in networking, we have to understand that a lot of the webinar sessions, the whiteboarding sessions we've recorded so far, talk about the basics of binary, decimal, hexadecimal, MAC addresses and IP addresses, and so on and so forth. And we have to understand that in the realm of networking, for example, at layer 2, when we are talking about using MAC addresses, we use 48 bits, which is made up of 6 bytes, which is made up of 12 hex digits. And we separate these with a colon. So you may have a MAC address, for example, that looks something like this. Keep it simple. So a MAC address looks something like that. So we use hexadecimal, and these are actually hexadecimal digits, not decimal digits. We use hexadecimal digits at layer 2 in MAC addresses. In layer 3, we have IP version 4, and we have IP version 6. Now IP version 6 uses decimal to create an IP address of 10.1.2.3. IP version 6 uses hexadecimal to give us an address like FF02 0001. Now, I'm not going to get into the complexities of IP version 6, but just understand it uses hexadecimal. Now, both IP version 4 and IP version 6 then use binary in the use of network masks and access control lists. So your network mask and your ACL will use bit level manipulation to operate on those IP addresses. So layer 2 uses hex, just to make sure everyone understands. That could just as well be 0001 0A using the hexadecimal digits. Remember, binary uses 0 and 1, decimal uses 0 to 9, hexadecimal uses 0 to 9, and then uses A through F to represent 10, 11, 12, 13, 14, and 15. Binary, decimal, hex. Now we have other webinars on this, and I'm going to direct you to them for more information. So layer 2 MAC addresses, they use hexadecimal, 12 digits, 6 bytes. IP version 4 uses a decimal format of 4 bytes. And IP version 6 uses up to 128 bits, which is 4 times the size of an IP address, 16 bytes to represent an IP address. And I used a bit of a shortcut by using IP version 6 terminology to say that everything between these digits are all zeros. But again, I'll redirect you to the IP version 6 webinar for that one. So we have to have a good grasp of hexadecimal, decimal, and binary when we operate inside networking, and we have to use them interchangeably. It takes a lot of practice to do this, but you start recognizing things and you start getting used to it eventually. The key is practice. There's a couple of things I wanted to mention here when we talk about binary and decimal, 10 to the power of 3 is 1,000, and 10 to the power of 6 is, of course, 1,000,000. Two to the power of 10 is 1,024. And I'll just mention here for our European, in particular British watchers, that a billion in America is 1,000 million. In the US, it is 1,000 million. In the UK in particular, a billion is 1,000,000 million. Okay? So when you see that the deficit or a submarine or a aircraft carrier costs $1 billion, it's not actually as many dollars as you might think. I mention this because in technology, we tend to refer to a billion as being the US representation. And I've actually messed this up, apologies. I should have drawn that over a little way and then referred to it as, oh, I seem to not be able to do this. There you go. I love live demonstrations, aren't they fantastic? When they work, they're fantastic, right? In technology, we refer to a billion as 1,000 million. The American, the United States standard mode of operation of 1 billion. Okay, so 1 gig being a billion bytes is 1,000 million bytes. So going back to this, 10 to the power of 3 is 1,000, 10 to the power of 6 is 1,000,000, 2 to the power of 10 is 1,024. I mention this now because if you have a 1 megabyte of RAM, you actually have 1,024 times 1,024 bytes of RAM. If you have a 1 megabit link of your service provider, you have a 1,000, you have a 1,000, apologies, my mouse seems to be misbehaving. It's actually a wireless mouse, and maybe somebody turned the microwave on or something. I may be being a little bit comical there, but you'll be surprised at the interference we can actually get. Anyway, 1 megabit is 1,000 times 1,000 bits. Now, it's not the byte to the bit that signifies it here. It's whether or not you are using it within the realm of computing, or whether you are using this within the realm of networking. So the networking aspect of compute, I'm sorry guys, I really seem to be having a bad day writing with my mouse here. Let me try and delete this completely and start again. If it's computer, PC based, it tends to be the 1,024. If it's network based, it tends to be more likely the power of 10 based. So when you buy a gigabit link from your service provider, you're getting 1,000 times 1,000 times 1,000 bits per second. When you have 1 gigabyte of RAM, you end up having 8 times 1,024, apologies, 8 gigabytes of RAM is 8 times 1,024 times 1,024 times 1,024 bytes of RAM. Okay, so if I got 8 gigabytes of memory, it actually ends up being a little bit more than the individual components of 8 gigabits of network throughput. The 24 makes a difference in the total number. So I wanted to mention that to you, that in networking, when we talk about connection speeds, we really are talking about a megabit being a million bits, not being mega and kilo with respect of bytes, that is 2 to the power of 10 mega and kilo. So understand that in the 2 to the power of mega and kilo, they're powers of 2. In the 10 mega and kilo, they are powers of 10. So networking use power of 10. Computers, RAM, hard disks, they use the power of 2. And the last thing I want to talk about in this session is something that can confuse an awful lot of people. It is some terminology that you may come across and may be confused over, because the tools that we use may explain to you to help you understand, and they may show things differently. From the perspective of computer technology, whether it's networking or compute resources, when you write down a number in binary, for example, like 10, 10, 10, 10, this is the most significant bit, and this is the least significant bit. Now, the significance we mean with respect to the number. If you change one of the most significant bits, the number changed drastically. If you change one of the least significant bits, so the rightmost 3 least significant bits are the 3 bits on the right. If you change one of these, the number changes by a small amount. So, for example, if you change this leftmost significant bit, you change it to a 1, the value of the byte now changes by 1. If you change the leftmost significant bit, the leftmost most significant bit, the value can change by 128. So the significance in the number is more towards the left. Quite often as well, you may see bits being numbered like this. The 0 bit, or bit 7. You may also refer them as bit number 1, bit number 2. Just understand that different references talk about the first bit, the second bit, the third bit, and so on. So here we are really talking about the first bit, the second bit, the third bit, the fourth bit. This is represented in binary as bit 0, bit 1. So we number the bits from right to left. Okay? So when you talk about bit 7, you're talking about this guy, or this one on the end, on the leftmost. The leftmost bit is bit number 7. Now, some vendors may show you, vendors or references, may show you bits written like this. That's because it's easier for us to read as human beings left to right. So human beings, we read from the left to the right. Now, just like we can talk about this with bits, we can also talk about bytes. And I've written MSB and LSB in lowercase as a bit of respect for a B for a bit is always written in lowercase. We also have the MSB, the most significant byte, and the least significant byte. So in a string of bytes, we normally draw them from left to right, but please understand that each of these may be representations of 1 byte. Each square represents 1 byte. So the most significant byte is the one on the left. The least significant byte is the one on the right. Now, I don't want to get complex here, but different computer systems may store things least significant byte first or most significant byte first. But from the perspective of this series of webinars, it's all about, we want to talk about mainly networking. Now, there are 2 protocols that we use in networking today. That has changed over the years. Over the years, we've had Ethernet, Token Ring, ARPANET, and so on. The two main protocols we use in local area networks today is, of course, Ethernet and Wi-Fi, wireless networking. Okay? Both of these operate in the same way. They operate in what is known as MSB first. Most significant byte first. So you transmit the data like this. You transmit that, then you transmit the next byte, then you transmit the next byte, then you transmit the final byte. So time progresses. As time progresses down the page, you transmit the bytes. Let's call them A, B, C, and D. So you will transmit A, then B, then C, then D. So you transmit as we read in the West, from left to right. However, be aware that both Ethernet and Wi-Fi, when they actually transmit the bits of the frame, the individual bits, one individual bit is transmitted from the right to the left. Okay? It is transmitted right to left. Now, I don't know if it's easier for you to understand that we transmit right to left. That means that Ethernet and Wi-Fi transmit least significant bit first. Now please understand the uppercase for MSB representing byte and lowercase for LSB. MSB, LSB in lowercase is a philism. It's me. It is not an industry standard. I'm trying to show you that here I'm talking about bits. So it's usually better in this context to use the full name and say that Ethernet is most significant byte first, but least significant bit first. And it's very important to understand this. First bit transmitted in Ethernet signifies, is it multicast or broadcast? So the first bit that is transmitted, if it's a 1, means that the frame is a broadcast or a multicast. If it's a 0, it's a unicast. Well, a lot of people get really surprised that when they see a multicast address, it should start with 80, because that would represent that. There's a lot of confusion on this, because what happens is the multicast address actually starts 01. The bytes are transmitted as a part of the frame left to right. But the bits, the individual bits that make up the byte, are transmitted right to left. So the first bit you see is the least significant bit over here on the right hand side. So just a recap, I want to make sure you understand. Ethernet and Wi-Fi transmit bytes left to right, but each bit is transmitted right to left. Now the reason I mention this is because it can be confused, because some vendors, they write down the bit numbers left to right, and they show you the job of that bit, and other vendors show you the bits written right to left. The bit number has a job. It doesn't matter how it's shown, just remember that that bit number is shown in a particular way. Okay. And remember that as things are transmitted, those bits will be sent from right to left in the byte, whereas the bytes themselves will be transmitted from left to right. So as a recap, we wanted to talk about, make sure we all understand, we've talked about binary, hexadecimal, and decimal, but now we wanted to talk about, make sure everybody understands how binary, decimal, and hexadecimal fits into our networking world. We talked about how MAC addresses use hexadecimal. IP version 4 used decimal for the address and binary for the masks. IP version 6 uses hexadecimal for the address and binary for the masks. We talked about how the power of 10, the power of 2, can confuse the megabyte and a megabit. It depends on whether it's used in the context of a computer function or a network function. We cleared up that it's better to be a British billionaire than it is to be an American billionaire, because they have 1,000 times the money. We talked about that. A little humour there. And we talked about how we transmit byte, most significant byte, left to right, but within the bytes we transmit the most significant bit last. It's least significant bit that gets transmitted first. And that's the end of our session today. Trust you learned lots, and we'll see you next time.